We often talk about mass and weight as though they were the same thing. But are they? The answer to that question is no. Mass and weight are actually two different things. For example, here is a man reading his weight on the Earth's surface, and the scales tell him that he weighs 100 kilograms, which is about 220 pounds. Now here is where it gets confusing. At the Earth's surface, the weight of the man in kilograms is equal to his mass in kilograms. If you weigh any object on the Earth's surface and record the weight in kilograms, it will equal the mass of the object in kilograms. And because we all live on the Earth's surface, it is natural for us to talk about mass and weight as though they were the same thing. But now let's go to the moon's surface and have the man weigh himself again. He is very pleased with what he sees. The scale now tells him that he weighs 16.6 kilograms, or about 36 pounds. On his fast trip to the moon, it looks like that he's lost 193 pounds. But how can that be? He still has 2 arms, 2 legs, 2 feet, his fingers and toes. So his body mass must be the same. And in fact, it is. His mass is still 100 kilograms, which is what it was on Earth, and yet his weight is 16.6 kilograms. So on the moon, you can easily see that mass and weight are two different things. The reason the man weighs less on the moon is because the moon's gravity is 1/6 as strong as gravity on Earth. The moon is much smaller than the Earth and has far less mass, so its gravity is significantly weaker. Therefore, the weight of an object depends on the gravitational force pulling it downward on the scale. So if you weigh an object on the moon, which has 1/6 the gravity of Earth, the object will weigh much less, even though its mass has not changed. Mass is a measure of the amount of matter in an object, and it is not dependent upon gravitational force. The mass of an object remains the same, no matter whether the object is on Earth, on the moon, or out in space where there is no gravity. Let's look at another example that will help us understand the difference between mass and weight. We will put the piggy bank on the scale and see what readings we get, and then determine its mass and its weight. The scale shows 200.1 grams. We will make 2 assumptions about the scale. Number 1, that the scale is on the Earth's surface, and number 2, that the scale has been properly calibrated so that the number we see on the screen can be used for both weight and mass. Now we know the weight of the object. It's 200.1 grams. And we know the mass of the object. It's also 200.1 grams. We have learned that weight is a measure of the force of Earth's gravity pulling the piggy bank down on the scale. And we have learned that mass is something totally different. Mass is a measure of how much matter the piggy bank has. We are going to increase the mass of the piggy bank by putting more matter into it. We will do that by adding pennies. Pennies are a form of matter. Each penny has a mass and a weight of 2.5 grams. We're going to put in pennies until we get a mass of 250 grams. we need about 5 more grams to get to the 250 mark. Let's just put in a nickel, because a nickel has a mass of 5 grams, and at the Earth's surface, that will equal 5 grams of weight. So our piggy bank now has a mass of 250.2 grams, and because the scale is on the Earth's surface, the weight of the piggy bank is also 250.2 grams. But now let's take the piggy bank and the scales far out into space, where there is no gravity. Out here, the mass is still the same. All the matter is still here, including the piggy bank, the pennies, and the nickel. But the weight has gone to 0, because there is no gravity to pull the piggy bank down on the scale. The difference between mass and weight will probably always be a bit vague in your mind. Your science teachers will often use the terms interchangeably because they do not want to confuse you. And it is not vitally important that you understand the technicalities that are involved with these concepts. But in college, it is important that you know that mass and weight are different, and that mass is a measure of the amount or quantity of matter, and that weight is a measure of gravitational force. Now it's time for a CAT, a comprehension assessment test. You will have 5 questions, and you will have about 15 seconds to answer each question. Let's begin. Question number 1. True or false? The mass of an object is the same as its weight, no matter where you are in the universe. If this is true, write A. If the statement is false, write B. Question number 2. Mass is a measure of A. Weight, B. Time, C. Matter, or D. Gravity. Question number 3. Weight is caused by A. Electric charge, B. Time, C. Energy, or D. Gravity. Question number 4. If an object has a weight of 200 grams at the Earth's surface, what is its mass? Is it A. 20 grams, B. 200 grams, C. 2,000 grams, or D. 2 grams? Question number 5. If an object has a mass of 10 grams, what will its mass be if it is far out in space where there is no gravity? Will it be A. 20 grams, B. 100 grams, C. 1,000 grams, or D. 10 grams? Now for the answers. The number for the mass of an object and the number for its weight are the same only at the Earth's surface. If you go to the moon, the numbers are much different. Remember, mass is a measure of the amount or quantity of matter in an object. Weight is a result of gravitational force. Without gravity, there can be no weight. At the Earth's surface, weight and mass have the same number, but that happens only at the Earth's surface. The mass of an object does not change unless matter is added or taken away from it, no matter where it is located in the universe.